everyone. This is Jest 2021 questions. Let's solve one by one. Okay. A monochromatic linearly polarized light with a electromagnetic field E is equal to this much. Okay. Is incident normally on a bifringent calcite crystal. The wavelength of the wave is 290. And this is not visible. 290 nanometer. And the refractive index of the crystal along x and y directions are 1.66 and 1.49. Okay, if the thickness of the crystal is this much, what will be the polarization of the light that emerges from the crystal? Okay, basically question is, if this is the calcite crystal and this electromagnetic field is coming containing x cap and y cap, it's the wave. Okay, then what will be the emergent light polarization? Okay, it's the calcite crystal and the refractive index of in the direction of x is mu x is 1.66, mu y is 1.49. Okay, and that coming wavelength is 590 nanometer and thickness of the crystal is 434 nanometer. Okay, and this electric field is this much. Okay, no matter. Basically we have to find the phase difference of the emergent wave, so that we can find out whether it's linearly polarized or circular polarized or elliptically polarized. Okay, as we know, phase difference is equal to 2 pi by lambda into path difference. The path difference is T. Okay, thickness, that is thickness. We don't have panic about that. But here lambda, as you know, when a wavelength passes through any medium, its wavelength decreases by mu. Okay, so 2 pi by 1 by lambda 1 minus 1 by lambda 2, as the two waves are coming, so into delta x is the T. Okay, 2 pi lambda 1 is equal to mu 1 by lambda 1, lambda is okay minus mu 2 by lambda 2, but here lambda 1 is equal to lambda 2, that is coming wavelength same, and thickness T. So 2 pi mu 1 is 1.66 divided by lambda 1, and that lambda is 590, take common 1.49 into 434, that will be pi into 0.24, which is nearly equal to pi by 4. So This is our phase difference pi by 4, and in case linearly polarized light, phase difference is 0, 2 pi, 2n pi, as we know. But in case circularly polarized light, phase difference must be pi by 2, 3 pi by 2, n pi by 2. Okay, and amplitude must be same. And in case elliptically polarized, any phase difference rather than these two will be the elliptically polarized, whether its amplitude same or not. Okay, so here phase difference is pi by 4. That's why the emergent ray will be elliptically polarized. This is our option D. Okay, let's go to the next question. A flat soap film has a uniform thickness of a flat soap film. Okay, this is soap film has a uniform thickness. T is equal to 510 nanometer. Okay, white light having wavelengths in the range 390 to 700 nanometer. Okay, it is incident normally on the thin film. If the reflective index of the soap is 1.33, then what will be the dominant color of the reflected light? What will be the color? And we will see this color. This is observed by us. Suppose this is I. Okay. So we have to find the reflected wavelength basically. Okay. And as we know, in case white light, the light wavelength is ranging from 390 to 700, that is the visible range. 390 to 700 nanometer. And according to Vibro, VIBGYOR, this is the lowest wavelength and this is the highest wavelength. So you have to find that reflected rays of which color. Okay. As you know, phase difference is equal to 2 pi by lambda into path difference. Here path difference is the thickness T. 2 pi by, and that when a wave is coming that is reflected from the any medium, then wavelength will be decreases by mu. So that lambda is equal to lambda into mu into T. So 2 pi by that given lambda is 510 nanometer into 1.33 and thickness is there is no given wavelength. We have to find lambda. 1.33530 divided by lambda, and that is phase difference. In case so film, that phase difference will be from the wave is coming from air, so that will give phase of 2 pi, as you know. And but in case glass medium, it will also give a phase difference of pi, so total phase difference will be, this is 2n pi and this is pi, this is 2n plus 1 whole into pi. This is the total phase in case reflected light from any medium, that is glass medium. Okay, so phase difference is equal to 2n plus 1 whole into pi is equal to 2 pi into 1.33530 divided by lambda. So lambda is equal to 1.33 into 530, 2n plus 1 into nothing. Let us take n is equal to 1. So 1.33 into 530 divided by 3 is equal to 452 nanometer. This is the wavelength I take as n1, so my wavelength is this. So this wavelength will in between this, maybe that is green, because in option there is nothing color rather than V and R, that is violet will not, because 452 will not be the color of violet or red, and white not, because white is the combination of all color, and the one option is left, that is green color. That will be the answer. Okay, let's go to the next question. Consider a spherical cell of radius r have Consider a spherical cell of radius r having a uniform surface charge density sigma. Suppose we construct a spherical Gaussian surface having the same radius k, but its center shifted from the charge sphere by distance r. What is the total electric flux through the Gaussian surface? Basically, question is given that this is the original place of that sphere, but our Gaussian surface will be on that surface, but Gaussian surface shifted at a distance r. So the total flux enclosed is a Gaussian surface from Gaussian surface law, as you know. So flux passing through the Gaussian surface is the only this surface. As you can see, this distance is same r and r, and this is the surface. We have to calculate flux passing through this surface. As you know, flux is equal to Q enclosed by epsilon naught is equal to integration of E dot ds. Okay, so that implies This is the full surface, but we have to calculate the flux passing through this surface only. So the elements will be changed. Okay, how it's changing? Let's see. Okay, the flux is equal to sigma dot ds divided by epsilon naught. It's the value of q enclosed. As we know, the surface charge density is equal to surface not ds element is equal to r square sin theta d theta and d phi. So sigma dot r square sin theta d theta d phi. We have to take integration, surface integral. Not 3, 2 divided by epsilon naught sigma dot d. Okay. Sin theta d theta and d phi will be 2 pi. But theta will be changed because we have to calculate the flux in between the area, and this is it gets messy. We have to calculate here. Okay. See, this is r, r, r. This makes equilateral triangle, and equilateral triangle angle is pi by 3. That is 60 degree. So 0 to pi by 3. Sigma r square, so sine is cos 0 to pi by 3 pi equal to sigma r square 1 by 2 into 2 pi sigma r square pi.